Corey, would you mind? Thank you for pressing record. So I have Corey Dillon here with me as well, who is a part of the membership department at SAE. And I'm Amanda Hildebrand. I'm the membership manager. And thank you everyone for joining us today for this chat on electrification. We are recording this, like I just said, so it will be available afterward if you want to view it. We're going to post it in Member Connection. And as a reminder, in addition to this live session, we also have the online discussion as part of Engineers Week in Member Connection. So again, I'm just going to act as a moderator, and I will just kick things off by introducing our hosts. And I'm just going to call your names out in alphabetical order. And if you could just give us a quick introduction, that would be great. And then we can start with questions. If those of you on the phone don't have any initial questions, I am going to round robin and ask all of the experts one of their questions that they provided to just talk about that. So let's get started. So first is Evgeny. Again, I think I did that right. But why don't you just go ahead and introduce yourself?
Okay, I'm Evgeny Ganev, CEO and owner of Electromechanical Power Systems consulting company. The focus of our business is electrification, both in aerospace and automotive businesses. Previously, I worked for about 30 years for Honeywell Aerospace as a chief engineer in the same area, electromechanical power systems, where obviously the predominantly aerospace experience being exercised, but I have quite an experience with military ground vehicles and passenger cars as well. So the focus is powertrain in both segments of businesses, and more specifically the electrical processing unit or electric engine for aerospace or electric traction drive system for ground vehicles. Glad to be here.
Can't hear you.
And I went, you would think after all this time, I would be better with the mute button. But what I want to say is I didn't mention, thank you so much to all of the experts that are volunteering their time to do this for us. All right, so next is Grant. Grant, why don't you go ahead and introduce yourself?
Yeah, good morning or afternoon, depending on where you're hearing from. But Grant Lawton, I've been with W.L. Gore and Associates for about 12 years. And my degree is mechanical engineering, but I work in high-speed digital wire and cable, as well as airframe wire and cable. And it's really kind of fascinating in the whole mobility market, just how the needs are manifesting themselves in terms of material properties, environmental properties, the voltage ratings that are being looked for now. It's really amazing. So it's a very exciting time to be in this industry as a whole new wave of technology is about to transform transportation. So that's exciting.
Absolutely. Thank you so much. Timothy Newcomb, you are next.
Hey, I'm Tim Newcomb. I'm a strategic technology manager at the Lubrizol Corporation. Been there for 8 years. Before that, I had a long career with Borg Warner. I'm a materials lubricant guy. And it's always interesting. There's such a blending of technologies in the new electrification space. People sometimes think of the lubricant as just adopting the ones we've used previously, but actually putting electric motors in touch with lubricants and things actually changes the characteristics. So it's a pretty evolving time, and we see a lot of different focus changes in that area. And it's interesting with all the different types of engineers coming together. There's sometimes a lack of familiarity with one part of what we've been doing with the new part. So it is a transitional period. Happy to be here.
Great. Thanks, Tim. Okay, and Josh, you are next.
Amanda, so Joshua Portlock from Electro Aero, CTO, developing electric aircraft charging standards. So I'm the chair of the SAE 7D committee, where we're developing aircraft charging and energy storage standards. And the standard I've been sponsoring is the AS6968, which is specifically focusing on the lighter duty aircraft charging, but we're also working on a AIR 7357 for megawatt charging standards. So happy to be here and look forward to sharing some insights into aviation charging with this great group.
Thank you. Okay, I don't see Stan on here, but Stan, correct me if I'm wrong. Okay. And then Michael Terzo, are you on here either? Because I believe you were not able to make it, but I just want to double check. I don't see you. Okay, well, then now that all the experts have gone around and introduced themselves, does anyone want to kick us off with a question? Please just speak up, raise your hand, and if there aren't any questions initially, like I said, I will go around and ask the experts some questions to kick things off. We also have the chat box if anyone would like to ask a question via the chat box. Okay, let me start again. We'll start with the first question. This is kind of a big one, but Yevgeny, what are the major goals of electrification? And I should also note that while I'm asking this to you, because this was one of your starter questions, please, the rest of the experts, if you want to weigh in on that question, or if anyone else has questions related to that, please, this is supposed to be a dialogue.
So any supplement to the question, or should I start talking about this?
Just kick us off. Just, when you thought of your starter question, which is what are the major goals of electrification, what were you thinking around that? And I think, once you start talking, that's going to help others, think of things that they want to ask.
So actually, this question was asked during the chat, and I responded with several bullets. So I can go through these bullets and explain a little bit further, right? Just because it was just the list of the answers,
Perfect.
not necessarily the details. So the first one is reduction or elimination of fuel consumption and liquids. So overall conversion of the energy is much better. So elimination of fuel from certain platforms is really something which is very helpful. It's much safer. And liquids, when we are talking about liquids primarily for aerospace and even for automotive, there is quite a few of those, right? The larger the number of liquid is, there are more difficulties. And the leakage, some of those liquids are fire hazard liquids, right? So elimination is really a big progress by electrification, just because we need much small number of liquids when the system is purely electrical or electric hybrid, no matter aerospace or automotive. Improved overall energy utilization. When you look through the conversion from the source of the energy all the way to the utilization, you can see that the total losses or overall efficiency is much better compared to conventional engines, right? No matter ground vehicles or airplanes, right? Just because those efficiencies are no more than 35, 40%, even for the best engine. That means the rest is losses only for the engines, and we are not including the rest of the energy required to produce those fuels. More efficient energy transfer. It's not coincidental that the power distribution systems on ground are predominantly electrical. So this is the most economical way to transfer energy. The losses are very small part, very 1%. So the same with systems which are electrical on any vehicle, the losses are minimal. Eliminated or highly reduced maintenance. Where it's coming from? Simplicity of the systems. An electrical system is much simpler, or electromechanical to be more accurate, just because we have very small number of components which are exposed to high temperature, and even high temperature for electromechanical power system, we can consider high as 200 degrees C, while in internal combustion engines or turbo machinery, these are thousands of degrees. So you can imagine that the maintenance of such a system is much easier, just because in many cases, these systems and many of the components, most of the components do not need maintenance. They don't need maintenance throughout the entire life of the vehicles quite frequently. Eliminated or highly reduced contamination. Of course, when we don't have internal combustion engine or turbo machinery where we are burning fuel and having many different liquids, contamination is pretty much eliminated. Reduce safety hazard. We have to be a little bit careful, just because most of those systems, electrical, electromechanical, contain batteries, and this is one of the biggest problem for rapid transition towards electrification, right? The safety of the battery is still a big concern. However, just think about a hazard battery compared to a hazard fuel, right? So if we start comparing these two, we can say that in the beginning, a fuel will be much more dangerous compared to a battery. But there is a lot of progress in this area as well. Substantial noise reduction, right? No comments. Electric rotating machine is creating very small noise. The propeller is probably the largest source of noise. However, it's tremendous improvement. No comparison at all. Improve reliability, improve dispatchability, which to a great extent comes from reliability. And again, I touched on this one. Reliability improvement is primarily because of the much smaller number of components and parts, and also the component systems and parts are exposed to much lower temperatures. More environmentally friendly system, right? This is the green technologies, reduce CO2. Again, this is one of the strongest selling point towards electrification. Drastic change of urban transportation. So whatever is targeted as a urban air mobility is completely new model of people moving in urban area. It's going to change drastically the people behave, improvement in the green technology as well, right? Completely different business model and the people's behavior. Here we have to talk about problems like social acceptance and overall reduce cost and time of travel. So there are certain benefits in this area, especially when electrical systems are combined with autonomous technology, which is applicable both for ground vehicles and airplanes, especially when we are talking about urban air mobility. It's clear that in the beginning, it's going to have a pilot, and upon the progress of the social acceptance, it's going to turn to autonomous operation. And this is some kind of further clarification of my bullets. Now, if you have questions for more details, I'm ready to answer or to have a formal discussion.
No, that's great. We did have a question come in, but I also wanted to give a chance if any of the other experts wanted to weigh in on any of that. I see that Stan actually joined us. Stan, we did a quick intro of all the experts, if you wouldn't mind just
Sure.
introducing yourself to the group.
Stan Serpento. I'm an independent consultant working for a client that's doing commercial vehicle advanced powertrains. And I've had, I guess, over 40 years experience working for a major OEM, General Motors. Worked on a lot of vehicle programs, many of them electrification, and try to stay engaged with SAE. I think besides staying current with technology, I think we need all hands on deck because this is a very disruptive time. It's also the most exciting time to be in the industry.
You know what, Stan, that's actually a good segue. And just to kind of go with that for a second, one of Grant's questions was, what do you see as the most exciting upcoming electrical technology? And Stan, since that was like a good segue, why don't you go ahead and mention kind of what you think is the most exciting, and then we'll jump back over to Grant because that was his original question.
Okay, as far as the most exciting electrical technology, I would say we're starting to see real breakthroughs in battery technology, getting to the longer ranges that are ultimately going to be able to be at parity with the ranges that people are used to between Philips, and also safer. Some examples of that are the solid state batteries, although I don't know if they have yet the same energy density as the current batteries, but there are many fronts trying to improve the battery technology, which ultimately, since that's going to help the range, and also lower the cost. It'll help get the total cost of the vehicle to be on par with internal combustion engines, which today I think is a challenge with most people. Is the
Oh, Stan, I think you're cutting out.
Oh, sorry. I was going to say, yep. Well, actually, I was finished.
Oh,
Yeah.
no problem.
Yeah.
All right. All right. Well, I'm actually getting a lot of questions here over in the chat. So, Josh, if you do want to just go ahead, or I'm sorry, Grant, rather, if you would like to just comment on what you think is the most exciting upcoming electrical technology, and then I want to get to the questions that are coming in through the chat.
I'm sure. Yeah, I got a lot of questions for everybody all at once, but I'll stick to the topic here. I think probably the technology that's coming through is the power that higher voltage motors can facilitate, and like just the need for the high voltage systems in terms of motors, batteries, and wiring, and power supplies in general. It's just the other knob to turn to try and save the weight, because you can't just keep laying in more copper and making everything bigger and heavier to handle capacity. So the voltage really is becoming something very important to enable a lot of these power systems to, in flight. So, it's all a system. Everything is interrelated and everything matters. And one of the things that I think Jenny was saying is, reduce maintenance because of 200 degrees C temperature limits. And every component's got its own temperature limit. Wiring, we can push it up to 260 degrees C. So that can reduce maintenance in terms of you don't need a cooling system, or maybe you go that high and you have cooling, which, it just depends on where the technology is taking you. So it's kind of fascinating. And the other implication is high voltage in flight is an envelope that is not totally understood, but the experience that is gained, like people just haven't been operating terribly high voltage systems at high altitudes. And there's, corona inception is, a factor that needs to be designed around, and, you can't let it happen. So it definitely gets more challenging at altitude. And if you want to fly, then you're at altitude. So I think the high voltages are the part that's really intriguing to me in terms of what it means to motors and batteries and power transmission.
Okay, thank you. And all right, so let's start. Just so you guys know, typically we don't get a ton of questions from the audience, and we usually have to do this round robin of asking the experts, but that is not the case with this chat. So I want to then start with a few of the questions that are coming in. So Carl was asking, what are the challenges / concerns with megawatt charging? Is there one component that you feel is the weak link? So whoever would like to jump in first to answer Carl's question, please do.
Certainly, I can certainly address it from an aviation charging point of view, because we're working on that. We're working on an AIR, so Aerospace Information Report for megawatt charging, the 7357 report. And really the biggest challenge for aviation megawatt charging is the cable management. Trucking is not as bad in the sense that you're pulling a truck right up next to the charger, and you can generally optimize that cable length to be quite short. And you're basically, for that sort of level of power, you're probably roboticizing the connection. So you have sort of a known height and location that the charger is likely to be. So moving the charger, the plug, from a cabinet, basically a charging cabinet, to the plug into the truck it's not an easy problem, because you're dealing with thousands of amps, but it's much easier than, say, a aircraft with 30 to 50 foot wingspan, and it's parked out on the apron or at a vertiport, say, and you have to bring that charging cable out to the aircraft. So the cable management of just physics of moving that much copper and cooling it as well, so liquid cooling these giant cables, is going to be a big challenge for the aviation industry. And I think that still is a challenge there in terms of total power. When you look at the truck stops of the future, when you've got, say, hundreds of trucks having to all take megawatts of power at once, that's going to be a serious infrastructure challenge. And we're seeing that with some of the bigger vertiports that we're designing smart hangars for. When we start looking at how many of these powerful vertical takeoff and landing aircraft want to land and fast charge within the same 5-10 minute window, you're needing like multiple substations to support that infrastructure. So we're addressing that with our smart hangar technology and adding sustainable energy and storage buffer batteries. But yeah, and then the last point I'd make is the coupler itself has been a lot of work and effort by the SAE committees and other committees around the world on the megawatt plug itself. And I can show some images of the latest plug technology if we're interested. But basically being able to pack a huge amount of current through a small coupler that's still human liftable and finger safe has been no small feat. That's been quite a work of art from a lot of great committees.
Hey, Josh, this is Grant Lawton. I got a question. In terms of the high-speed charging, why is it that the vehicles aren't looking at a rotable pool of replaceable batteries as opposed to charging the battery on the vehicle at high speed instead of just swapping the battery?
Yeah, battery swap's been a heavily discussed, or at least debated topic. In the automotive world, it's generally not proven to be as economically viable. There are some battery swap stations in China where they're successfully swapping batteries for luxury SUVs, where time is more critical than value of like electrons. But you've got to look at the big infrastructure tail end of that, right? So every time you do a quick swap, say a 5-minute swap of a battery, well, it's still going to take at least half an hour to an hour to charge that battery. So you've got to go and have at least that many batteries, being charged in the back end to service those quick, several minutes of swaps. So I think there's that kind of almost ignoring what's behind the curtain challenge, that you still have to physically charge those batteries. They still take a certain amount of time to charge. So you're kind of offloading the problem. Now in aviation, small enough aircraft that have small enough batteries, the battery swap probably makes sense, like the 1 to 2 seaters, and where the batteries are quite compact. But when you start dealing with some of these bigger eVTOLs, and certainly the fixed wing commercial airliners in that 9 to 19 seat category fixed wing, or even the 5-seat eVTOLs, the battery is so big and so structural in order to be lightweight that it's quite a logistics nightmare to change that battery. So I'll give you an example without mentioning any names that might be under NDA. But say you've got, let's say, a 300 kilowatt hour eVTOL battery. Well, that's not only about 3 to 4 Teslas worth of like in capacity, but it's distributed in, say, 6 to 8 compartments around the airframe. So in order to distribute the mass and to keep the weight down, it even sometimes forms part of the structure. So now to like physically remove 8 separate structural batteries every time you want to land, that's logistically way more time consuming than fast charging. So that's one of the reasons why aviation is not likely to adopt swapping batteries. I think automotive has the nice luxury of it being a big slab underneath the floor, but even then it's got that tail end logistics challenge of actually how many batteries do you need to actually benefit automotive turnaround times, especially now that you're getting sort of 3 to 5C charge rates. So people are fast charging in, say, 5 to 15 minutes, depending on how much capacity they want. It could probably take about that long just to swap the batteries.
Mm-hmm. Josh, do you see any help from the wireless charging technology to reduce the need for long cables for megawatt charging?
Unfortunately not. I've been really hoping and watching the wireless charging standards. I obviously love wirelessly charging my phone, as everyone does, and I'm hopeful that there's going to be wireless slow charging for cars in the future that is affordable, and you don't have to physically plug in your type 1 or type 2 AC cable every night. But I think when you get even in the tens of kilowatts, like we sell 30, 60, 80 kilowatt chargers, to deliver that much power even, let alone megawatts, through wireless, the wireless charger itself ends up weighing nearly as much as the battery. So for aviation, it's definitely not going to earn its place on the aircraft because of the weight alone. But then the losses are also not negligible. You're talking about tens of percent losses in the wireless transmission. So you've got the inefficiency, and the weight penalty is not conducive to aviation, that's for sure.
Josh, obviously your focus is charging stations and batteries. Have you considered to deliver not only charging to the battery, but cooling of the battery, just because the battery limitation in time is primarily thermal issue?
It's a great question. And what we are doing for our aviation customers are offering active air cooling as a supplement to our chargers. We did explore the idea, and we are on an ongoing discussion with a few airframers about liquid cooling through the charging coupler. But to get everyone to agree on that, and for it to be a repeatable, plug-inable, like flushable system that everyone standardized to, is, I think, probably an impossible task. So what we're more likely to do is, supplementary to the charging standard, the physical coupler that has the copper and electrons, we'll be offering active cooling, basically ducting, that's part of the charging solution, but it's not necessarily part of the coupler. And our preferred medium ends up being air, for at least aviation anyway, because you typically are cooling your batteries through a means of air conversion anyway. You're either forcing air straight through the batteries, or you're doing like a air to liquid radiator. So if you've already kind of taking in high velocity air when you're flying, then whatever intake duct you've taken that air into, we're basically offering an air conditioning to help blast chill that air intake while charging. So we think that's the best, somewhat universal solution. It does mean you probably have to have like air intake ducting adapters. So say there's like a different knackered duct for different aircraft and different size inlets. You'll have that sort of adapter for that aircraft, but then there'll be like a universal tube that you can plug onto to air cool the batteries while you're fast charging.
Thanks.
First, I'd like to say that I'm a strong proponent of electric vehicles. Recently, I've had a lot of conversations with my SAE colleagues who are educated car guys, and they seem to be really nervous about fires. Can anybody comment on the battery fires and where that's going and that whole situation?
I can certainly, if no one else is going to jump in, but we've firsthand seen, because we've been in the industry for 7 years doing electric aviation, 8 years I think now, and we've actually seen and heard of battery fires under prototype testing. So it does happen, but I would say the majority of designs are very safe now, and it's really a chemistry. Fundamentally, it's a chemistry thing. So the lithium phosphate batteries are far safer than, say, nickel, manganese, cobalt. But the high performance batteries, like a say Tesla Performance or Long Range, are still using NMC. But the way they keep them safe is using many small cylindrical cells that are individually cell-fused. Means that they can cut themselves out if they thermally run away and short circuit. They can cut themselves out of the circuit. So individual cell fusing is one technique that we definitely adopt in aviation, so that if there's a thermal runaway, it's isolating itself fairly immediately. And the other thing in aviation, which is different to automotive, is parallel redundant pairs, multiples of pairs of batteries is very common. So anywhere from 2 to 8 parallel batteries aircraft. There is a thermal runaway event or a risk of a fire. You can basically disconnect that parallel string so that it doesn't energize and keep flying off the remaining batteries. So there's several layers of safety these days. I think automotive is tending towards, for certainly passenger cars and non-performance cars, tending towards phosphate, which is inherently safer. And then for high performance batteries like sports cars and aircraft, which by nature need high performance batteries, there are mechanisms to make them safe. But one last point I'll make is, it's funny because we've just gotten used to driving around with a exploding fuel tank, a fuel tank of exploding petroleum in our boots, like of our cars, and that's okay to us because it's been designed to be safe enough. But just looking at the statistics, it's far more likely for a petrol car to catch fire after an accident than an electric car. So from a accident induced fire point of view, batteries are actually quite inherently safe comparatively.
Josh, how about solid state batteries? Where we are with this technology?
Yeah, I'm certainly following it with anticipation. There are probably some other experts that can chime in here more than me, but it's also been a lot of empty promises. That's been a little frustrating in the sense that they have promised a lot in one area. So say it's like super fast charging, that's great. But then if you look at that same battery that can super fast charge, it's got like a quarter of the energy density or only a few hundred cycles of life, or there's some other limitation that makes it not a whole, an overall competitive solution. There is, which is important for aviation, that solid state's promising, but it almost always doesn't survive the torture test of temperature and life cycle performance. So, for instance, like there are some solid state batteries that people are using in long endurance solar aircraft that can operate like all day off the sun and then all night off the battery, and they'll last about 30 to 60 days. But then the battery's basically lost half its capacity by the end of that cycle. So while that's good for that specific use case of like a multi-month electric aircraft, it's pretty useless if you're having to replace your batteries every 2 months, or less. So there's a bit of a challenge in life cycle performance in solid state that I'm seeing, and cost is still pretty exuberant, getting that cost down.
All right. Well, this is great discussion, and I don't want to temper it at all. So, if there's more to say, please make sure that you throw any other questions in the chat box. But we do have Another question from Pete, who had asked about, do you think the range anxiety zeitgeist has been addressed with a broad enough population in America? Any thoughts on that?
Can you elaborate on the question? I'm not sure what it means, the last part about broad enough. Could somebody elaborate?
Pete, are you on here? Would you be able to elaborate on your question?
So if I might try to clarify, this is Grant Lawton. If I heard the question correctly, and I saw some discussions in the chat, is that there's still the goal is trying to get the range on a full tank kind of range on a full battery aspiration, but in reality, the studies of the day-to-day needs are usually not a full tank of gas, so to speak. So I think they're saying, like, can we readjust the expectation so that people don't need to go 300 or 400 miles a day? Is that where the question was coming from?
I can't speak to it for sure if that's where it was coming from, but that makes sense to me that it's more just the anxiety around how far you can go and maybe explaining that and educating folks in this country about that information. So I think that's a fair response. And Pete, not to put you on the spot, but if you did want to, oh wait, let's see here. He did write some more. Do you think range anxiety has been addressed sufficiently to deliver a sufficient electric vehicle adoption rate? Okay, so there, thank you, Pete. Any thoughts, experts, on it being, explained sufficiently for the adoption rate?
Yeah. I think each consumer is going to have their own perspective. The person that drives mostly local is not going to have the same perspective on range as, say, a person who spends, twice a week making a living traveling on the interstate from one town to the other, and depends on the availability of charging stations along the way.
Yeah, I can add to that I've had first-hand experience every time I used to travel on business to the US more often pre-COVID. I'd always hire electric cars, and I'd drive Teslas and I'd drive Chevys, and I'd tried different electric cars out. And by far the more important factor than the actual range of the car was if there was charging infrastructure, because even a Chevy Bolt has enough range between what you'd want to comfortably stop to eat or go to the toilet, and like the human factor of wanting to stop more often is probably more prevalent than actually the range of the car. But whether that place you conveniently stop at has a charging station is the bigger concern. And like I had to, for instance, as in California, there's a huge amount of superchargers for Tesla, so there was no problem. Just wherever you went, there's always someone to charge. But there's still, at least 2 years ago anyway, there was still a limited number of Electrified America stations, and it was more of a planning exercise to make sure I was stopping where there were charging stations rather than the other way around. Then, oh, I need to stop now. Where's my nearest charging station? So yeah, I think the infrastructure is the dominant factor more than the range of the car, in my opinion. So I think it's more as the Electrified America network, gets even larger and eventually probably overtakes the number of Tesla supercharging stations, then the general public will be more confident with the non-Tesla charging network.
And the good news is the infrastructure is improving day after day, right? Very, very fast, right? No way back.
For sure. Yeah.
Yeah, I have to agree with that, but there's still a way to go. Just a year ago, my brother's got a Tesla, and one of his challenging experiences was driving down the Pennsylvania Turnpike, where you only get an exit every 20 to 30 miles, and if he missed his exit and he needed a charge, like, that was a problem. but hopefully every rest area at every turnpike and every exit will eventually have a charging station. I mean, that's what, to your point, that is what is going to allay everybody's fears.
However, keeping in mind that 99% of the cars stay still, are not in use, right? There is a very good news. For instance, here in Los Angeles, in California, people can go to work with electric car with no doubt about this, right? Even going to Las Vegas, cross country may be still difficult. However, easily, a family typically has minimum 3 up to 5 cars or something like that. Easily half of the cars can be electric, just because during weekend you don't need more than 1 car, right, for family travel.
All right, great. We have another question from Carl. What trade-offs are designers making when it comes to partial discharge? Is there one trade-off that is more important compared to the others?
Partial discharge. Can somebody find what that is?
So that's the corona inception voltage and corona extinction voltage. It's the ionization of gases around the convectors. So it can have a deteriorative effect on insulation if that actually occurs within the insulation. So there are certain insulation materials and wire types that could be an inception point inside the insulation. It's less certain how much the wire is degraded if it's occurring outside.
Thank you.
And the other thing is it's getting more complicated, right? It's not only corona inception voltage or creepage or some other effects. When we are looking about deep reliability of the components, let's say electrostatic machines and power electronics, those needs to be understood not only from corona perspective, but also from power quality perspective as well, and the VDT, what primarily electric machine experience. There is a combination on the deterioration, the effect between these two events, right? So it's really something which everybody agrees that higher voltages are creating lighter systems. However, those are not very well understood. So this is why the progress is so slow. But nevertheless, the progress is done. People comfortably go to 800 volt nominal voltages now in aerospace, and can easily double this voltage really soon.
We're getting a lot of indication that the sought after voltages are no less than 1,000. There's roadmaps for 1,500, 3,000, 4,500 and higher, and it's a field in need of a lot of study.
Yeah, long way to go. A lot of
Trends.
studies and testing as well.
Yeah, there's definitely a trend towards the 800 volt nominal battery voltage for aviation to reduce the copper weight from the typical 400 volt systems, and even sports cars are going there as well. But there is somewhat of a glass ceiling for aviation at the moment at 1,000 volts because of corona discharge and because of insulation breakdown risk at altitude, because you do have issues as aircraft fly higher with thinner air density and whatnot. So the AS6968 charging standard is up to 1,000 volts at the moment, and that's proven to be challenging. Just even going over 900 volts, you have a lot less components to choose from and whatnot that are still altitude tolerant. But then the megawatt charging standard is up to 1,500 volts. I think it'll be a while though before people confidently aircraft at 1,500 volts. I think trucks make a lot of sense at 1,500, 1,300, 1,200 volts. But aviation seems to be gravitating or kind of staying a bit more conservatively under 1,000 volts because of the altitude aspects.
All right, thank you. We have another question. Will people want to tow a battery pack like a phone battery pack is used today? Can you connect an additional battery pack? What about standardized connections and various charging locations on the vehicle? Any thoughts?
I'll happily give
Hey,
my
this is Grant Watton again.
thoughts. Yeah. No, look, I
Uh,
mean,
uh,
my concern with towing, say, a battery is the drag of the towed device. So, you know, generally cars are getting slipperier and intentionally more aerodynamically efficient. So because that's the main consumption of energy is fighting drag. You go and put a trailer on the back, especially like a conventional box trailer, it's really destroying that range. So you've got to question the value of adding drag in order to add more storage battery to only consume the storage battery faster. That's not to say you couldn't really go to town and like making an aero trailer that's maybe like just the right shape to conducively, you know, reduce the drag of the car in front, but it's not an easy task, and it would be very, you know, very vehicle specific trailer to actually gain anything from doing that.
I can
And
see
the mass, yeah. So
potentially. Sorry, go ahead.
yeah, no, just someone mentioned the mass as well, right? So you're using more energy to accelerate the weight of the trailer and more energy with the drag penalty. So it's a kind of vicious circle of adding more to only get a little less more, you know?
I was going to say it's probably not out of the ordinary that the military would consider doing that, though. You know, towing a battery in certain mission
Sure.
applications.
Yeah. Yeah, I mean, I think the idea of, you know, solar trailers are effectively going to replace generators eventually. You don't want a noisy diesel generator running when you're certainly at the front line, but even in commercial use cases of where generators are set up, makes a lot more sense to have a big trailer with a fold-out solar array and a massive battery, so that you've got, you know, temporary power on demand. I think that's generally going that way, but solar still needs to come down in cost a little bit to justify that sort of non-fixed infrastructure use case. And I think getting the battery to there is not the reason you're using it. You don't necessarily use it for an source while getting somewhere, but once you're there, serving as a stationary, like a trailer full of batteries, as a stationary, you know, power, it makes a lot of sense. The only reason why that opportunity might become less important or less so relevant is that the battery is getting so big in cars and so cost effective that the car itself is the mobile power station. Like you look at the size of batteries going into Ford F-150s and Cybertrucks, like that's a 100 plus kilowatt hour battery. It can deliver, you know, say tens of kilowatts if you needed to. So that becomes your like genset replacement. You know, the vehicle itself is the energy source.
Okay, great. You know, let's move to, so I think that's pretty much all of the questions we have. We have a few more questions for the group. Tim, why don't you talk to us a little bit about, now this is shifting from batteries. Tim's background is in fluids. So do we want to talk, Tim, a little bit about one of your questions, which is perhaps how are HEV / EV fluids different from internal combustion engine only vehicles?
That sounds more microscopic in detail what we've been talking about. I actually was thinking that in the conversation we've had, one of the things I find exciting about the area is that with the changes we have in the automotive industry, it actually also is to make the carbon dioxide numbers from all the different talks and things I've seen. We need to be seeing a change in the overall way we handle energy around the world and in the country. So I was thinking in terms of, we've been talking about batteries in terms of the kind of batteries we get powering vehicles, but in terms of energy storage, I think some of the ideas of converting some of our power plants over to greener fuels, I think that the impact the moving to electrified transportation is having is going to have a large impact on our infrastructure. And maybe I'll go back to what I know more about the lubricants, but I just wanted to throw that out. People like comments about, because I find that one of the more exciting things about the way the industry is moving, because it's going to affect a lot more, in a greater part of how we handle energy.
No, I think that's great. And, obviously this conversation can take any direction that we want it to. So
But I'll
Thank
talk
you.
a little bit about the thing that's very interesting about what we've been seeing in terms of going to hybrid and electric vehicles is
yeah,
that there is actually a change in the way we view lubrication within the vehicles, and that I spent a lot of years working on automatic transmission fluids, and we think of those fluids as being there to control friction, to make sure your power transfer between the engine through the transmission is smooth and effective. And so you tend to think of the fluids being geared a lot toward that characteristic. And now what we're finding is, because of these, the motors and the power, we find that now the concerns about the fluids are more, would they provide a path for leakage current? How do they protect the copper? Copper corrosion is always kind of a thing that lubricants have to protect against to prevent corrosion. But it becomes a more important thing when you start having these electrified systems. And so our whole view of how we're looking at the way lubricants are, how they can enable some new efficiencies in terms of both keeping, enabling the motors to run cooler, and keeping the, I want to say, the resistance of the fluid enough that you don't have charge buildup for moving fluid systems or turbo-charging, and at the same time don't allow leakage paths and things. So it's been a very kind of exciting time. I think this is one of the bigger changes that we've seen in terms of driving fluid direction to enable even more efficient designs. But that's a microcosm. As I said, I think it's also really interesting about what this change in this industry is doing to other industries and our overall way of thinking about power.
Yeah, and Tim, also we can recognize that lubrication liquids can be eliminated, especially when we are talking about small size of vehicles, passenger vehicles, and also small aircraft, 2 seats, 4 seats aircraft. Lubrication system may be pretty much eliminated.
Yeah, I think we're going to still see quite a bit of lubricants being used in this area. The volumes will go down, but the kind of lubricants will change. And I think
you don't necessarily need a large amount of oil for lubrication or cooling.
Yeah, but now it takes on more than just lubrication. I mean, when I talk to the engineers who are designing these systems, they talk about, again, the lubricant being used. Some of them won't even refer to as the lubricant; they'll refer to it as the motor coolant. And the whole idea of the heat transfer properties of the fluids becoming much more significant, and how we manage that is interesting. I mean, it's a very different perspective of the things we're taking.
Exactly, right. There's a lot of space to learn and improve it. And also we can talk about gearless, oil-free kind of systems, which are have been tested to very high power levels. We can talk about direct drive for electric machine and for passenger vehicles. In the Hub machine, the same direct drive, no gearbox for small aircraft.
Yeah, so one of the things, a general thing I'd like to share is, I was at one of the last powertrain fuels and lubes meeting. There was a lot of keynote speakers around trying to achieve carbon dioxide numbers and targets for the whole concerns of, the concern over global warming, and that without changing power grid and how we do things and manage other power, that even if you were to switch all, I remember one of the speakers showing some numbers that if you changed everything to electric vehicles today, we wouldn't be able to achieve those targets, partly because of the cars in the park that are still out there using fossil fuels, but also because of the way power is distributed, and how a lot of our power is still generated through fossil fuels, and how to turn that into more green energy, and then how to even store, once you go to, I want to say, solar and wind, how do you store that energy in a green manner, so you don't have that carbon dioxide concern. And I think it's very fascinating that the industry is actually starting to drive changes in those other industries.
I'm sorry I came in late, but I had a question about, you mentioned storage. And I wondered if anybody's looked at standardizing a bidirectional connection for all of the electric cars that come into system. So in effect, you turn all of the millions of cars that we're going to have on the road into a robust grid backup and storage facility.
I've heard
Generally
that.
called vehicle to grid. I can touch on that if no one else is that experienced.
Please
Yeah.
go ahead. I was thinking of a different alternative than that, but yeah, go ahead, please.
Yeah, so vehicle to grid technology is definitely booming at least in the standards world. So, for now, most AC charging is one way and some DC charging is bidirectional, like CHAdeMO have a vehicle to grid standard. However, CHAdeMO is a dying standard, so it's unfortunately going to not necessarily carry forward. Now, CCS 1 and 2 are promising V2G, at least in the standards section of what they're capable of doing, but whether the chargers themselves have supported it yet is a bit lagging. Vehicle to anything, or V to E, I think that's the buzzword, vehicle to basically power things like I talked about in the construction sites, V to A or V to, like to be able to run your power tools and things like that off the cars is definitely happening. And then in Ford F-150's announcement recently, they're going to do basically a smart charger for your house, that your house can use the car as its backup battery. So in the loss of power event sort of situation. So it's definitely coming. I think between Tesla, Ford, and the primes, they'll have their own little version of it. And unfortunately, at least between Tesla and others, there'll be separate standards just by nature of Tesla doing their own proprietary stuff typically. But everyone else who's, say, adopting CCS1, that'll hopefully become a bit more standardized. And certainly the truck size batteries, when you've got 100 plus kilowatt hours of batteries, that's enough to like power a home for days. So it's definitely more than enough for backup power. And you can definitely be sucking up the excess solar in the middle of the day and using it in the afternoon. And you wouldn't even really break a sweat on still having enough range to drive it. When you're dealing in the smaller passenger car category in the low tens of kilowatt hour batteries, then you start to question if you actually want to be cycling your car's battery every day to help with your solar, time of day tariffing and things like that. So it is a sizing issue. Someone mentioned it there. Only makes sense if it's an oversized battery, but that's actually happening now, at the point where most people have a far bigger battery than they drive every day. So if you allow a certain capacity of your battery, and within reason, you're only allowing, say, 20 to 30% of your battery to be used for time of day tariff arbitrage, where you're sort of shifting the excess sun from the middle of the day to the afternoon when there's peak power, that could really make quite a difference. And just the last point I'll make is that people are much more willing to put an extra $10,000 into a nicer car than they are willing to put $10,000 into a storage battery on their house. I mean, there are diehard energy enthusiasts who will buy Powerwalls and will do the energy storage because they believe in self-sufficiency, and I'm a big advocate for that. But it's more likely that people will spend more on their cars than they will on a home battery. So I think V2G kind of allows that conversion of overspending in the vehicle to then have that renewable battery supplementing the solar on your house.
Yes, and on a grid scale, even if you have you'd set limits on how much you could draw down the batteries in your car, but you're talking many gigawatts if you're talking millions of cars in the system. And so I think it behooves the auto industry to talk to the power industry about merging the two interests as we go to more and more renewables into the mix.
And what I'd say is, as the grid gets more sophisticated, it actually allows the vehicles to respond more dynamically. So there's a technology we're working on that's becoming quite popular called virtual power plants, so VPP. And virtual power plants is the idea of community batteries all acting together for the common good of that embedded network or that local, power utility. And that's almost more important to have everything communicating really fast and responding quickly than just the total capacity of the battery. So for instance, in California, there's currently a really good, incentive to support peak shaving and to support the instantaneous loads, and even to the point where just frequency correction becomes more valuable. They call it FCAS, frequency augmentation control, is actually more valuable than just the total capacity of a battery. So how much power the battery can put back into the grid at the right times can be more valuable. You can actually make more money off correcting the grid's instability than you can off overall capacity.
Yeah, and I think that there's a mutual interest here that really ought to be pursued. But thank you for your input. I really appreciate that.
No worries.
Okay, everyone.
Amanda, how are we going
so-
for time? We're on the hour?
Yes, no, I was just going to say, unfortunately, we're at time because this was such a great conversation. I hope everyone got a lot out of it. But the good news is that we still have the online discussion in Member Connection with all of the experts. So if you have a question that didn't get answered, or if there's something that pops into your mind, it's going on the rest of today and then also tomorrow. So we put the link in the chat. So it's just connection.sae.org. If you go to the top under events, it's the Engineers Week activities. And also just want to mention we have activities going on every day this week for Engineers Week. So definitely get in there and check out that link to see what else we have going on for everyone. So thank you so much. This will also be recorded, as I mentioned, and we're going to post it in the online discussion as well.
Thank you very much, Amanda.
Yes,
Really-
thank you so much, everyone. And I hope you have a good rest of your
Thanks,
day.
Amanda.
Thank you.
Thank you, Amanda. This was
Thank you.
really nice.
Oh, wonderful. I really appreciate all of your time.
Okay. Bye-bye.
Take care. Bye-bye.
Okay, bye-bye.